Today's lesson is 4.2, Day 2. Our objectives today are to convert between exponential and logarithmic functions and equations, solve exponential equations, solve problems involving exponential and logarithmic functions, and differentiate functions involving the natural log. Your classwork/homework for tonight will be 4.2, number 2, and you'll be doing page 315. 30 to 62 evens. The first example I want you to do is to just take your calculator out and make sure that you can use the natural log button the right way. First, find the natural log of 5.24 and make sure you get that answer on your calculator. And then type in the natural log of that and make sure you got that answer on your calculator. When everyone's gotten these answers, please continue the presentation. Our next topic is exponential equations. I know you've done these before, but just to remind yourselves, if we have on example 1 e to the t equals 40, you will go through and take e to the t equals 40, make both sides multiplied by the natural log, and when you put both sides to the natural log, this power will come down in front. So now I have t times the ln of e is equal to the ln of 40. The natural log of e is 1, so therefore I have t is the ln of 40, which on your calculator should be approximately 3.7. The only difference with example 2 is that you have it raised to a power that has a number in front of the t. So you put both sides to the natural log, you're going to bring down this power out front. The natural log of e will just go to 1, so you'll get negative 0.04t is equal to the natural log of 0.05. Then I'll divide by negative 0.04. Using my calculator, I should get that t is approximately 75. As far as solving using graphs, I will show you more of this method tomorrow in class. We'll pull up the graphing calculator and I'll show you how you can do both of the different methods. So we'll save this slide for tomorrow. Going through and talking about graphing natural logs, go to your calculator and graph the natural log. You're going to get something that looks similar to this. And it's a little bit bigger of a scale. You'll have something that's a little bit closer to the x-axis over here, and this point here is the point 1, 0. So therefore we have a couple different on theorem 6 we have a couple different properties. The first one is that the natural log of x exists only for positive numbers of x. So you'll never get anything over on this side of the graph for the natural log of x. So the domain is 0, infinity. This line x equals 0 is our asymptote. Now the second one tells us that the ln of x is less than 0 when x is between 0 and 1. So that's kind of right in this area. It equals 0. ln of x equals 0 when x is 1, and then it's greater than 0 when x is greater than 1. So that's this part of the line. The range of the entire line, so the range, remember, is the y values. It can go from negative infinity all the way to positive infinity. The extension of today's lesson is to understand the derivatives of natural logs. So theorem 7 tells us the derivative of a natural log is just 1 over x. Now if I have something other than x right here, I'm going to have 1 over whatever exactly that is times the derivative of the inside. So you're kind of like using the chain rule there. So as an example, if I had the derivative of the ln of 2x plus 5, then my derivative would be 1 over exactly what's in here, so that'd be 2x plus 5, times the derivative of that, and the derivative of 2x plus 5 is 2. So you would get 2 over 2x plus 5 as my derivative for that expression. We're now going to go through the examples. So our first example is A, the derivative of 3 times the natural log of x. I want you to go through and hit pause. As a class, please try that example and then hit play when you're ready to see the answer. Okay, so the way I would do it is that it's 3 times the derivative of the ln of x is 1 over x. So your final answer would be 3 over x. Our next example is B. And that's the derivative of x squared ln of x plus 5x. So be careful when you do this example, because you're going to need to deal with the product rule here. Try the example and then again hit pause as a class, and when you're ready, hit play. Okay, so if we go through this example, the first thing we're going to do for B is that I'm going to take the derivative of x squared, so I'll get 2x ln of x plus x squared times the derivative of ln of x, which is 1 over x, and then I'm going to add the 5. So my final answer should be 2x ln of x plus x, because this will reduce, plus 5. And that's your answer for letter B. On the next slide, we'll do examples C and D. When you are ready as a class to proceed with the solutions to examples C and D, go ahead and hit play. On example C, you are going to have the quotient rule. So when you take its derivative, you're going to have the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared, so that'd be x to the 6. I can take out, this will be x squared minus 3x squared ln of x over x to the 6. So if I take out an x squared from everything, I'll get 1 minus 3 ln of x over x to the 4th. And that's your final answer. On D, D is going to involve the chain rule. So this is like you have the ln of u. So you take 1 over x squared minus 8x times the derivative of the inside, which is 2x minus 8. So as your final answer, you're going to write 2x minus 8 over x squared minus 8x. So at this point, why don't you try doing examples E and F, and when you're ready to see the solutions, please press play again. Okay, so the derivative, we can treat this like u. So I'll have 1 over 3x times 3. The 3's just cancel, so I get 1 over x. on this derivative, this is like my u, so I have 1 over x squared minus 5 times 2x. So my final answer is 2x over x squared minus 5. Take a minute now and do g and h, and on our next slide we'll go over that. Hit pause and then hit play when you're ready to see the solutions. Okay, so for g, this is your u, so that means I have 1 over the natural log of x times the derivative of the natural log of x there is 1 over x. So your final answer should be 1 over x ln of x. Now for h, you can use the properties of natural logs and make this a much easier problem. So I can now take the derivative of the natural log of x cubed plus 4 minus the natural log of x, because of the fact that it is the same thing as me saying it's the natural log of m over n. So taking that derivative, I will get 1 over x cubed plus 4 times 3x squared minus 1 over x. So my final answer there is 3x squared over x cubed plus 4 minus 1 over x. As we progress, we can put this under one fraction, but for today's lesson I won't make you do that.